Hi, this is the People's here. My name is Melody Leonard, and in this tutorial, we'll be looking at service-oriented architecture. I'll definitely understand what a service is, the idea of the service-oriented architecture, how it tends to solve the current problem we have in a monolith application. So the current way and the traditional way we build an app is you spin up a server. It could be a Node.js application. I'm a Node.js engineer, so I probably would use Node.js. You know, you spin up a Node.js application, and you have this you know, you have everything put inside that server. Right? So you can write a function, a handler for an email. So what happens when you want to call an email? Probably you have a create user, function. You create a user, and what happens? You want to send them an email that they've been created, right? Or the user has been created with so and so details, and probably you want to send them an email also to uh, create their password or whatever, or change their password or however you handle your business logic, right? What you do is, you probably have another function, and you know that is send email, probably connected to whatever email server you want, and you could use uh, you know SendGrid or just anyone out there. Uh, you call that as well. And this is an issue. Say you deploy something, or just say something happens, and probably not from your end, right? It could be from the third party SendGrid, right? Something goes wrong in SendGrid, and a process is not working, right? And say probably you were expecting a data, and you're trying to see, get this data. Once it gets the data, you want to access a method or a property of that data, and you go ahead and do some logic. And when this happens, you see that you're getting undefined dot something, and that is going to, for a Node.js application, is going to crash your server, right? And you have a tightly coupled system where know, it crashes your server, and probably a service is just down. And what happens is it affects other services. So you are struggling with probably creating a user because the server is just down, right? The entire server is down, right? And this might be something you could handle in a very small application, but if you have a very large business, right, this becomes an issue, right? Because you don't want your server to go down all every time, right? I mean, Facebook will lose customers or users if their server should be down for 24 hours, right? 24 hours is just me, taking to the extreme, right? But Facebook will definitely lose users if their server is down for probably 8 hours, right? The entire Facebook is just down for 8 hours. People will pull out of Facebook and stuff like that. But we've seen times where the messenger is no longer working. You can't send messages, or you can post, you can go through whatever news field and watch videos and stuff like that. So the service-oriented architecture tends to extract these services. So we have an email service, we have a user service, we have probably a video service, and we have a music service and stuff like that. The service-oriented architecture tends to extract these services and give them their own server, right? So what happens when you give them their own server? If the email service goes down, every other thing is working correctly. Every other thing is just working perfectly. And this is the idea you want. This is what you want, right? So you have everything working perfectly, and there is no uh, tightly coupled system where the email service uh, depends on the uh, user service, and probably the the user service might be down, right? Create user might be down, but there's some other logic that is calling the email service. So that could just go ahead and call its own email service, send mail and stuff like that, and everything is just working perfectly, right? And when you're looking at a service-oriented architecture where you have a decoupled system, where you have this independence, you have a couple system that allows you the benefits of a service-oriented architecture, right? You want to look at a useful way to communicate your information across the services. How do you communicate with across the services? So when you create a user, how do you want to communicate and tell the email service that, okay, hey, I created a user. Now, one way you could do it is have a gateway for each service. So when you create a user, you go ahead and use your fetch request or Axios request, and say Axios dot post or whatever, post this to the service, and it goes ahead and creates that user and stores it in its own database for that service. Well, that's it's one way you could do it, and a lot of people take this approach, but uh, that equally introduces an issue, where you're still calling functions, you're still manually calling these things, and say you have 5 services you want to notify when a user is created. You have to go ahead and call for each of these 5 services, passing this data for each of these 5 services. Well, people will say, okay, I could do, you know, like optimize my code in such a way that I don't have to write a bunch of code, right? And that happens. But if that single call, let's say you're running an Azure's post and you optimize your code in such a way that everything is just in one function, right? And that function goes bad. None of these services are going to receive whatever comes through, right? Because of course you could not execute the function, right? That brings us to uh, probably the main topic for today, which is the event-driven architecture. So the event-driven architecture tends to, utilize this idea of publish events. So when a user is created, you could just go ahead and publish an event user created, right? And whatever event is subscribed, whatever service is subscribed to this event, could just receive that and do its magic. Now, this tends to solve a lot of issues, right? So basically, you have a producer which produces the events you're looking at, and you have you equally have the message broker, which is right at the middle, right? And you have your should I say, you have your consumer, which is receiving the event. So the producer calls, which goes through your message broker, like Kafka or RabbitMQ, which are the most popular message brokers that are out there for handling this very complex system, right? And your and it's received in some service. And when that gets received at any time, it could be 1 year later, it could be 2 months later, it could be 5 hours later, right? And hence, it receives that, it just goes ahead and publish or do or call whatever the method is related to that event being received. And this is very, very beautiful, guys. This is very, very beautiful. So why should you even consider the event-driven architecture? So we are looking at, the event-driven architecture. It solves the problem of not calling or should I say, your services by hand, or using the traditional way. So why should you consider it? One, it creates this decoupling system. Like we said, your system is just decoupled, right? So your user service doesn't even need to know that something like the mail service exists in life. So it's not calling the mail service, in any way. It's not even calling the gateway for the mail service at all. It doesn't know that the mail service is existing somewhere, right? And it creates this dependency, inversion. So your user service is no longer depending on or your you know is no longer aware of your mail service, right? But your mail service is just out there listening for an event that comes through from the user service, right? So see, there's this dependency inversion, right? So your mail service is just there listening. Okay, is there anything coming from any place here? Where is it coming from? Or if you want to go in detail, put in descriptions on where the service that sends and that sends an event or publishes an event. Now there's this it improves scalability, right? In a very large organization, and in a case where there are tons of services, let's say 50 services or 100 services, even on Facebook, you could have a situation where you have about 1,000 services or something, listening for one event, right? You know, you don't have to go ahead and start writing calls for each of these. And sometimes if something breaks, you start debugging, debugging the user service, trying to see where the call was wrong or something like that. And no, you don't have to do that. You just know that once you broadcast this, and probably if other services are receiving this, you know where exactly to debug, on where to go and get your answers. So there's no single point of failure, right? So there's just no single point of failure. You can't say, okay, there's just things there could be a situation where your service is down, right? In traditional way, if you call something, if you go ahead and probably try to say a user is created, you go ahead and execute a function, and your service is down. What happens? Probably, let's say it's a transaction, right? You make a transaction and the user gets received, you do your calculations and try to call a service in charge of saving that to database, right? And the service is down. What happens? That transaction disappears. Like it just disappears because that service is down. Well, for a service-oriented architecture, right, you're using a message broker. So you see that your message broker is going to queue that in its memory, right? It's going to store it, right? So whenever that service comes up, it's going to go ahead and publish that event to that service. So there's no single source of failure as well, and this is very, very beautiful. But then, if you look at the advantages this offers, you have to equally look at the disadvantages it offers. So, not really disadvantages, but there are some issues when you want to go very, when you want to scale. Every scalability, in my opinion, has a bit of an issue or has an issue. One, of course, is you have to get a larger team to maintain, you know, a microservice system, right? So if you want to go service oriented, or if you want to go services or microservice, you want to have microservices, and you have things decoupled and stuff like that. You have to get a larger team to handle these services, right? And you have to equally get a good, management, automated management system. Right? So you have to have, you could have your things running in a container, you could have your services running in a container, and you could orchestrate it with even something like Kubernetes and what have you, right? But looking at the event-driven architecture, there are issues with the event-driven architecture. And one of these is performance, right? So you see that sometimes you push you publish, you know, create user or user created, and it takes time to just get to this. And probably, let's say, five services are listening, so it's just not going to get to them at the same time, right? And probably that service is busy with something else, so it's going to probably queue up or stuff like that. And whenever necessary or whenever it gets it, it's going to go ahead and execute that. So another one is no consistency in regards to time. So there is no time consistency. You can't say it takes 2 minutes to execute this, for this to for user to be created and sent an email, right? Sometimes it could take 5 minutes. A good case would be when you want to perform a transaction, probably a transfer, a bank transfer, right? You you initiate a transfer. Sometimes it takes as soon as possible, like probably that moment. Sometimes it takes about longer because whatever events you publish is being queued and other things are in the queue which have been attended to sequentially or wherever the system was built. And there's more complexity, right? So when you want to handle an event-driven architecture, there's a more complexity. And even in debugging, right, there is no way you could say, okay, I caught this on this particular place. Like, you have to start looking and replaying the log and see what happens before you go ahead and you know debug the whole process. So probably the debugging process might be more visual than you could just go to. a piece of code and say, okay, this is how it happened. And sometimes you have to look at the log, when it's if when this message was broadcast, right? If it was received at all, and probably something like that. And if it didn't receive it, you have to start going through and see why didn't it receive it, and stuff like that. Uh, you know, this creates the mindset of okay, if there is an issue with this whole process, and of course there are advantages of having the event-driven architecture. When should I use this event-driven architecture or this architectural pattern? Well, one when you should use it, especially when you prefer to scale, when you prefer scalability over performance, right? There is a good chance that when you create a user, you're not going to get an email instantly, right? So the email might take 10 minutes, it might take 5 minutes, and which is a lot, right? 5 minutes is a lot. Like even 5 seconds can sometimes be a lot, right? So it might take 5 seconds, it might take 10 seconds, or sometimes a minute, and this is a whole lot, right? So performance is not the best you're going to have, and sometimes something is just holding a service, or something like that. So the service cannot really process the request at the time, which is being queued up, and when another other service is relieved of its or in increase of its current taxes, just go ahead and attend to whatever is coming through. Another one is when there is data replication, right? So you're looking at data when the data you want to call different services, notify different services of what's happening, right? In a service-oriented architecture, you don't have to call them one after the other. I say, okay, call this service as user call, whatever, or call this gateway, pass these parameters and stuff like that. Just push an event, and all these services that are subscribed to that event are aware when that comes to them, right? Another one is when you want a decoupled system, you want a really decoupled system where things are just not tightly coupled. The a service doesn't depend on another, and even when the user is being created, the user is not aware of the email service, so he's not calling the email service. And if you look at the code of the look at the code, and you're trying to debug around the or writing the code around the user service, you're not seeing anything that concerns the email service. So you don't even know if the email service was built off SendGrid, or if it was built off you know uh, load mailer or whatever out there, right? So you are not aware. There's no that awareness. There is no tightly coupled system where there is dependency on each service. Now, uh, uh, so far we've looked at the event driven architecture, and we said when you have your when you have an event, you just publish an event, user created, right? So this introduces an issue. Sometimes when that is published, or probably when you publish an event, user created. Now the email service will have to say, okay, I've received user created, but which user though was created? Probably it came with this user was created. Then the email service will say, okay, I've received that user with an user ID so and so was created. But what is the first name of the user? Or what's their password info? Like the create password link that was generated. What's their last name so I could apply it to append it to the mail. What other details, whatever detail you need. When was the user created? Was it 5 minutes ago? Was it 10 minutes ago? And stuff like that. Now, this brings us to an issue of the service still going back to the previous service and asking, okay, I got that this user was created, but there's this back and forth. It publishes another event. So, what user was created, or probably which user, and it gets a response probably in the next 5 minutes or 10 minutes, and that is pretty much redundant. That's crazy, right? So in the event-driven architecture, there's this concept of event carried state transfer, right? So the event carried state transfer tends to uh, allow events carry states. That's just as simple as it goes, right? you have your events and they are carrying states, right? So an event is having states. So when a user is created, say user created, you're sending along every data that that user, that email needs to get sent to that user. So the email service is not having any need to go back to the user service to look at, okay, why, or ask any crazy question or something. It just goes ahead and since it has the state, it just goes ahead and uses whatever data is necessary for its consumption and goes ahead, probably saves it in its own database, or this mail was sent or something like that, the mail URL or whatever, and goes ahead and sends that message. And this is very, very beautiful, guys. This is really very beautiful. So when you're looking at the microservice architecture, you're equally looking at a whole lot of other things. There are processes or points where you want to look at CQRS, and CQRS basically means command query responsibility segregation. So the idea of secret areas is not allowing whatever creates or the command, right? Whatever issues a command, like let's create user to get data, right? So when you say create user, you no longer there's a different, there's a different probably uh, different call or different events that is in charge of getting the data of the user created. Of course, when you create user, you want to get that data back, right? You want to get the infos of the data so you could send it to other probably other services that that needs to be aware of that, right? So CQRS introduces a situation where you just have do this and you no longer care. Something else is in charge of getting the data. So, okay, get this user was created 5 minutes ago and stuff like that. And of course, in our next tutorial, we'll be looking at CQRS in depth. And we'll equally be looking at, in this series of tutorials, we'll equally be looking at a whole lot of things, how we could apply Kafka to a real application, which is pretty simple. We are going to spin up a microservice architecture or a microservice app where we would have probably two or three services, and we'll have them communicate via Kafka, which is a very nice message broker. But you can feel free to go through the documentation around Kafka, which is very, very cool. Or you can equally look at the RabbitMQL, which is another cool message broker. And that will be it for the now. I really enjoyed talking to you about this, this knowledge, however you call it. And yeah, bye for the now. And guys, I must say this right. If you think the video quality or whatever is poor and needs to be improved, you could just subscribe, right? And that would encourage me to uh, you know probably at source for a better tools and stuff like that for recording and stuff like that. Yeah. And yeah, that's it. Take care, guys. Bye.